All right, welcome Math 1111ers. I have Latoya with me today, and she has brought a question here about compounding interest, which is a topic from 3.1. She's given me the information for it here, and the question asks you to calculate the accumulated value for the account semi-annually, quarterly, monthly, and then continuously. So these first three, semi-annually, quarterly, and monthly, the only difference in calculating these three is the N, the value N that you're going to use. The formula for compound interest is A, or accumulated value, equals principal times 1 plus the rate divided by the compoundings per year, all raised to the compoundings per year times the number of years that you compound for. Time is always given in years in this formula. So we're going to have the same P, R, and T every time we do this. The only thing that's going to change is the N. So semi-annually is twice a year, quarterly is 4 times a year, and monthly is 12 times a year. So I'm just going to do one of those calculations since the only thing that's changing between those is the N value. All right, so whenever you do these, you always want to write your formula down so that you don't have to spend a lot of time memorizing it. If you write it every time you use it, you'll know it when it comes time to use it again. So A equals, my principal is the amount of money I start out with either in an investment or as a loan. And in this case, the principal was $10,000. So A equals 10,000 times 1 plus my rate is 4.5%. You've got to convert that to a decimal. So the percent, you would want to divide 4.5 by 100. It's going to move the decimal place 2 spaces to the left. So I would write 4.5% as 0.045, just like you'd write 4.5 cents. I know we don't have half cents in our money system, but it's how you would write it. And actually, we do have partial money, and you see it every time you pump gas. If you notice, the price of your gas is not $3.69. It's $3.69, and it'll usually have a little 9 cents next to it. That means it's really almost $3.70. So there's that partial cents on the end, and they're always going to round up when it comes to paying for your gas. That's just a little tidbit to know. Okay, so my rate is 0.045 divided by N. Okay, so we need to decide which one we're going to calculate. For this example, I'll calculate quarterly. So we'll use an N of 4. Okay, so 0.045 over 4, all raised to the 4 times, well, it said for 6 years, so my time is 6. And now all I need to do is put this into my calculator. If I go and type this into my calculator, this is what it's going to look like typed in. I'm going to have 10,000 parentheses 1 plus 0.045 divided by 4 end parentheses raised to the, you can do 4 times 6 in your head and just put 24 there, but if it's something that you can't do in your head, you put parentheses 4 times 6 in parentheses. That's how I'm going to put it into my calculator, and I'll tell you what I get. And Latoya, do you have a calculator that you can give it a try there?
Yes, ma'am. I'm working it.
Okay, excellent. I want to know what you get before I put down what I get. Okay, so looks like Latoya has put into the chat window that she got $13,079.90, and I got $13,079.91. So we are good to go on that one. I actually got 0.91226, so it looks like, Latoya, did you just round to the 10th place on that?
Yes, ma'am. I forgot.
Okay, so be careful with that. Yeah, if you're talking about money, you always want to round to the 100th place, because my math lab will actually count that incorrect, even though you've done everything beautifully. Be very careful whenever you're talking about money, you want to round to the penny. Okay, so like I said, for those first three N's, we use the regular compounding formula. And then we have something called continuously compounding. In other words, the balance right now is different from the balance right now, is different from the balance right now because it's continuously compounding. So in this particular section, we saw that value E as N moves into positive infinity, that that formula 1 plus 1 over n to the nth power moves towards the limit E, that value E. So when you have continuously compounding, you have a different formula because n is moving into infinity. And that is the PERT formula, A equals P times E to the RT. So that's actually a simpler formula to use than the other one. So we have the same P, the same R, and the same T. The N is taken into consideration with the E. So A equals 10,000. E, in your calculator, you're automatically going to get a caret and an open parenthesis there. That means raise to, and I'm going to raise to the 0.045 times 6. So Latoya, go ahead and do that one in your calculator, and we'll double check each other and see that we get the same thing. Yep, okay, so I see that Latoya got $13,099.64, and that is exactly what I got. It probably asked you did it say which one's a better investment or anything like that?
Yes, ma'am.
Okay, so yeah, obviously you'd want to go with continuously compounding. It's only $20 more over the life of the investment, but if you're talking about a loan, you're paying $20 less over the life of the loan. So, you know, almost 6 1/2 a dozen, but it would you'd be $20 richer with the continuously compounding, or $20 poorer if you're taking out a loan there. Did that help you understand the problem, Latoya?
Yes, ma'am.
Excellent. Did you have another one you'd like to look at?
Yes, I have one more.
Okay, let me clear our page off. Do you need anything on this page right now?
No, ma'am. I got it all.
Okay, excellent. Let me go ahead and clear our page. And you can go ahead and let me know what the next problem is.
This one comes from 3.2, asking me Wait a minute, wait a minute. Give me 1 second. Sorry.
No worries.
Okay. It says the graph of the logarithmic function is given. Match the graph to the function. And the answers, it said which function matches the graph.
Okay, just give me the function, and I'll graph it out for you.
Okay. I'm assuming the thing is I don't know. It's asking me to give them the function. It already gives me the graph.
Okay. Okay. So you have to know your transformation properties. So the basic parent function of a logarithmic function would be the log of x, I guess.
Yeah, x is 0. X equals 0.
Okay, what are the choices that they give you for? Do they give you an actual function as the choice, or do they?
Yes, ma'am.
Okay, so tell me what your function.
Y equals negative log 4x. 4 to the x, I'm sorry. I guess that's what it is.
Okay. Let me correct that. Okay. Do you have other choices?
Yes, ma'am, but if you could just show me how to graph that, then that would help me instead of me giving you everything.
So let me just take the basic without the negative there. Y equals log of 4 to the x power. Okay. So log 4 to the x. Are you sure it's 4 to the x power? Because that's going to pull that x down out of the exponent. Are you sure it's not the log of 4x?
Let me check to make sure. It is the log of 4x. That's what it is. I'm sorry.
Okay, it's just, okay, that's okay. The beauty of technology, you can just erase it off. So y equals the log. Let's just look at the log of x to see what happens in its parent form here. So I'm just putting it into my calculator to give myself something to look at as I go through here. So let me point out that this is understood base 10 because it's the common log there. So basically this is asking you what can you raise 10 to give you an x value. So you want to choose the x's that you plug in very strategically. In other words, you don't want to choose a negative value for the x because you can't raise 10 to 10, which is a positive number. You can't raise 10 to any sort of exponent and get a negative number out. Does that make sense? In
Yes,
other
ma'am.
words, okay, so real quick, in other words, there's nothing that I can raise 10 to that's ever going to give me some negative value out. So when I go to choose the values that I want to plug into, and I really should have put f of x there, but we know that f of x is y, so I'll just leave it as y right now. We know that we don't want to choose any negative values for x in this parent form as it is. And also, I can't use an x value of 0 either, because there's nothing that I can raise 10 to that will ever give me 0. There's no exponent I can raise 10 to that will give me 0. Does that make sense as well? Because 10 to the something equals 0. 10 is a positive number. Again, the only way you can raise to an exponent and get 0 out is if your base is 0. So 0 to the 10th power is 0. 0 to the 20th power is 0. But there's never going to be a way to raise 10 to a positive exponent or to an exponent of any type and get 0 out. Are you okay with that?
Yes, ma'am.
Okay, I see the check. Let me clear your check off there. So we're talking about domain here. We're thinking out loud about domain. What are the possibilities of plugging into this thing? So I can raise 10 and get a value of 1 because, and you can watch my movement here in the function, 10 raised to the 0 power is 1. Well, we start at the base, raised to the is, and that equals the of. So that's how I'm coming up with these values. Is that okay, LaToya? Okay. So when I raise 10 to the 0 power, I get 1. And it's actually kind of easier to put your y values in first here. Okay, so 10 raised to the first power is 10. 10 raised to the negative first power will give me out 1/10. So do you see how I'm filling in this XY table? I'm kind of working backwards. I'm putting my Y value in first because that's what I'm raising to. Okay, cool. And we could say 10, let's see, -1. As soon as we raise to the second power, we're already up to 100. The square root is going to give us an irrational value. I'll just go ahead and raise it to the second power, and that's going to give me 100. Oops, that was 1,000. 100. And I could raise to the negative second power and get 1/100. Okay, so notice none of my x values came out negative because it's not going to happen, and none of them came out as 0 either. All right, so I'm just going to draw off a graph here. 1, 2, 3, 4, 5, 6, 7, 8. That's 20, and we'll say this is 100 just for the sake of our graph here. And then y, we have -1, -2, +1, +2. Okay, so we have the points. So this is considered the parent function here of log of x. 1, 0, right here. 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1. 1/10, -1, so about right here. 100, 2. 1/100th, -2, so even closer to the y-axis. So this is what this thing looks like. Your y-axis becomes that asymptote that that thing is approaching. And then I missed my mark, sorry about that. So it goes like this. And if you think about it, it's the inverse operation of an exponential equation. An exponential equation is going to look like this. It's going to shoot up really quickly. And remember, we learned back in chapter 1 that inverse functions reflect over the line y = x. So then all you have to think about are the transformations that have happened on the function. And they're the same transformations that we studied back in chapter 1 as well. I'm going to look and see if they give you a general form for that with transformations on it. I'm not sure if they, oh yes they do, transformations involving logarithmic functions on page 405. Well, I guess it's 405 of your textbook. I think I've got the older version here, but it's in section 2.3. There is an entire chart for transformations on logarithmic functions. So I can spit it out in shorthand down here at the bottom for you to help us understand the problem that you came with. Okay, so vertical translation, so vertical, that's going to happen outside of the function. So we have g of x equals log base b of x plus c, or log base b of x minus c. This is up and down movement of the entire function. So taking that thing and moving it up or moving it down. You good so far, Latoya? Okay. All right, and then we have horizontal shifting, and that happens inside the function. And don't forget, inside inverse is what we have happening. So when we have log base b of x plus c, this is going to shift, although it's a positive c, it's the inverse because it's inside the function. This is going to shift left. And then log base b of x minus c is going to shift right. C units. Then we have reflection. And that is over one of the axes. So when we have a negative log base b of x, This is going to reflect over the x-axis. And if we have log, I'm running out of room, base b of negative x inside the function, this is going to reflect over the y-axis. So the one you came to us with, we can see this thing right here is going to reflect across the x-axis, and the only thing we have left to talk about is horizontal stretching and shrinking. So that's the only thing that 4 could be, either a vertical stretch or shrink or a horizontal stretch or shrink. And we find out that g of x equaling c, so some coefficient being multiplied by the entire log, that is either going to be a vertical stretch or shrink, depending on the value, and you can go and look in the book and see what those values are. Vertical stretch or shrink. So in the y direction, the up and down direction. And then when we have that coefficient on the inside of the log, so log base b of cx, this is a horizontal stretch or shrink. On the inside, so it's going to be the inverse of what you would think. Does that help you think about it, LaToya? Okay, and pardon me, were you able to locate that chart that I was just telling you about? Okay, so you can go in and look at that chart and see the details of the stretching and shrinking, because you've got one happening there in the horizontal direction. And you might actually know enough from just knowing the other things to be able to pick the right, pick the correct graph. But I'll just show you what the page of your book looks like for that. In my book, it's page 405, and it's got the characteristics of logarithmic functions there at the top, and then at the bottom you have that chart that says transformations involving logarithmic functions. Was this helpful for you, LaToya? Did you get your questions answered?
Yes, ma'am. I thank you very much.
I thank you for keeping your appointment with me very much. And I'm sure everybody in the class will thank you for producing this video with me today, because I'm sure they are struggling with the exact thing. And I'll just remind everybody that the quiz will be opening this Thursday. So tomorrow at 12 a.m. the quiz will open up, and it'll be open through Monday night at 11:59, and final exams start for this class next Monday and go through next week. And don't forget, there's practice for your final exam at the bottom of your homework in my math lab. You do the same, LaToya. Have a great day. Thanks again.